Hi there, so today we're going to have a look at 14.4 drawing histograms. So our objectives for today to understand how to calculate frequency density and to be able to draw a histogram. Please make sure you have got a pencil and a ruler as well as your calculator ready before you start this lesson. Okay, so let's just check our prior knowledge before we begin then. So you should be able to draw appropriate axes for a single quadrant graph. You should be able to understand and read information from a grouped frequency table, and you should know how to find the area of a rectangle when given the lengths of its two sides, so as in the example here, and you should be able to find a missing side length when you're told the area and one of the sides of a rectangle. Pause the video now, make sure you're happy with all of that before you continue. Okay, so today we're going to have a look then at histograms. So histograms look like frequency diagrams. The main difference is that on our frequency, the frequency on our histogram is represented by the area of the bar and not the height of the bar. So we've got a frequency diagram here, and we can see that on our vertical axis we plot frequency. Frequency being the number of items, people, things that we are drawing our data on. Our histogram over here then, our vertical axis, we have frequency density. The frequency on our histogram is represented by the area of each of the bars as opposed to being able to read the height from the side of the bar. Okay, so that's our main difference, and our frequency density is our frequency divided by our class width. So we're going to have a look today at how to calculate the frequency density and be able to draw a histogram. So the second difference then that you will have seen is that in our frequency diagram the width of the classes is the same for each of the bars, and on the histogram the bars have unequal class intervals, unequal width. So if we had our frequency table here, we can see that these groups are in groups of 10. So each of these class intervals or class widths, whichever you like to call them, has a size of 10. Whereas on this one, the first one has a difference of 10, the next one is only 5 wide, 5, 5 again, and then 15 wide. So just go back to that previous diagram there. You can see our frequency diagram, all of the bars are exactly the same width, so that means they had the same class intervals. Our histogram, the bars are different widths as we go along, so they have unequal class intervals. Okay, so those are our two main differences. So as I said, we're going to be looking at a histogram, so we need to be able to calculate the frequency density. So we can't get the frequency from the height of the bar, instead we need to find the area of each bar and use that. So again, things in the green box are important, so please make a note of these in your maths book. So frequency is equal to the area of the bar, and frequency density is equal to the height of the bar. So the formula that we need then is to find the frequency density. To be able to find the heights of our bars, we need to do the frequency divided by the class width. So here we have a bar then. We can see that the frequency, the area of this bar, is 4 people, and we can see that the class width goes from 95 up to 105. So the frequency is 4, the class width is 10. So if I want to work out how high this bar is, I need to do frequency divided by class width, which gives me a height of 0.4. So exactly the same as looking at those rectangles in your prior knowledge. If I know the area of the bar and I know the length of one side, I can work out the height of the other side. Okay, so time for you to have a go then, just to check that you're able to find the areas of the bars and to find the missing length. So you've got 4 questions there. You need to find the missing piece of information. So pause the video now, have a go, use your calculator if you need to. Okay, so let's have a look at these then. So for the first one, I've got an area of 2 and I've got a side of 5. So to find the other side, I need to do the area divided by one of the sides. So our frequency divided by our width of interval, which gives us a frequency density of 0.4. For this one here then, we've been told the width of the bar is 10, the height is 0.5, so our frequency density of 0.5. So to find the frequency, the area of the bar, 0.5 times 10 is 5. On this one then, the width of the interval is 20 and the frequency density is 1.2. So 1.2 times 20 will give us the area, which is our frequency of 24. And finally then, I've got here my frequency of 8 and I've got my frequency density of 2. So I need to find the width of the interval. So we're going to do 8 divided by 2, which gives us an interval of 4. Make sure you're happy with those before you move on. So essentially we're finding areas and sides of rectangles. The area is the frequency, the height, the frequency density, and the length is the width of our interval. Okay, so we're going to work through an example then of how to calculate the frequency density and then how to draw a histogram with that frequency density. So we've got our normal grouped frequency table here. So these are the first 2 columns that you're always given. Remember, you will have to add on the additional columns yourself. So in any exam question, you're only ever given the first 2 columns and then you have to add in the rest depending on what the question asks you for. So we're going to draw a histogram. So we need to find the frequency density. Frequency density is the frequency divided by the class width. So we've got a frequency of 8. Our class width, we're from 95 up to 100, so that is a class width of 5. So 8 divided by 5, our frequency density is 1.6. For our second one, our frequency is 5. Our class width from 100 to 105 is also 5. So 5 divided by 5 gives us a frequency density of 1.0. For the next one, our frequency is 8. Our class width is from 105 up to 115. So that's a class width of 10 this time. So 8 divided by 10 is 0.8. Frequency of 12, a class width this time of 15. So 12 divided by 15 also gives us 0.8. And finally then a frequency of 2 and a class width of 20. So 2 divided by 20 is 0.1. So you'll often find these frequency densities can be quite small numbers. So when we're drawing our graph, we need to plan that out. So we don't want to have a tiny graph in the corner of a page. Remember, whenever we're drawing a graph, the bigger it is, the better. It makes it easier for us to read and easier for us to take information from. So now we've got our frequency densities. I know that the vertical axis of my graph needs to go from 0 up to at least 1.6, and my horizontal axis is going to be my time in seconds, and that has to go from at least 95 up to 150. So whenever we're planning our axes, check the values you've got and think about how you're going to equally space those across your page. So here's my axis then. I've got my time in seconds along the bottom. I've made sure I've labelled it. I started at 95 and I've gone up in 5s to 150. And my frequency density on my vertical axis from 0 up to 1.6, and I've chosen to go up in 0.2. So now all we've got to do is draw the bars in at the correct width and the correct height. So remember, the width is the width of the group, okay, that class interval, and the height is your frequency density. So from 95 to 100 we had 1.6. From 100 to 105 we had 1.0. From 105 to 115, 0.8. 115 to 130 was also 0.8. And from 130 all the way to 150 was 0.1. Okay, so you'll notice the bars are different widths as we go along and different heights based on our frequency density. Make sure you're happy with that before you move on. Okay, So now it's your turn then. So I've taken this from an exam question. So the first part of the question wants you to complete the table. So the table is the same as the one I used, except we've got the columns and rows going in the opposite direction. So you need to fill in the class width and then calculate the frequency density, and again class width and frequency density. Pause the video now and have a go at completing that table. Okay then, so for our first one then, our class width, we've gone from 65 to 80, so that gives us a class width of 15. Once we know our class width, we've already got our frequency, so frequency divided by class width gives us a frequency density of 0.5. For the next one, our class width is from 80 to 100, so that's 20, and 4 divided by 20 gives us a frequency density of 0.2. So now we have all of our information, we can move on to the second part of the question. So this time then, you've been given the axes. We're told this one's our frequency density in millions per year, that's what we're measuring in. You need to complete the rest of the histogram. So pause the video now, have a go at this in your maths book. Okay, so let's have a look then at the bars we should have drawn. So our first one then, from 0 to 16 was 0.7 high. We then went from 16 up to 65, so we've had to be careful there. 65 is halfway through a square, and that was 0.8 high. From 65 up to 80 was 0.5 high, and from 80 to 100 was 0.2. Okay, check your answers and make sure you are happy with that. Finally then, let's just look back at the key point from this lesson. So a histogram is a type of frequency diagram used for grouped continuous data. In a histogram for unequal class intervals, the area of the bar represents the frequency and the height of the bar is the frequency density. To find the frequency density, we do the frequency divided by the class width. Alright, well thank you for working through that video with me today then. Next lesson we'll be having another look at histograms and looking how we interpret that data once we have it.